I also want to mention, if you are dividing by something, like suppose I'll do this in blue. Suppose to get each next term, you divide by like 3. I wrote down multiplying specifically because we are actually only going to be multiplying. You can think about it as division, but when we write down the common ratio, it's always going to be using multiplication. So maybe some people can figure this out. If you are dividing by 3, what do you think R is going to be? It's going to be exactly 1/3. Because if I multiply by 1/3, that's the same thing as dividing by 3. And that's why I'm only writing multiplying, because that helps us keep R in a consistent way. Just like when I don't have it anymore, but just like when we have the common difference, if we're subtracting something, then the common difference is negative. Like when instead of subtracting, we're adding a negative. Well, instead of dividing, we're multiplying by 1 over whatever we're dividing by. Yeah? All right, let's do an example. So for the geometric sequence, that's 2, -4, 8, -16. State the common ratio and an explicit, that's a C, explicit formula, and find the 11th term. So there's 3 things. Common ratio, which is R, a formula, and finding the 11th term. Like we're using the same thought process, except for now it's R instead of the common difference, D.
And we would divide that. Or we would put like the 2 numbers.
Well, and then we also use this formula.
Okay.
Yeah?
All right.
So you're doing the same stuff except using a different formula. Because, it has to be a different formula because we're doing something different. We're not adding something a repeated amount of times.
Okay.
We're multiplying something a repeated amount of times. That's why we have an exponent. So for this, my first objective is to figure out how do I get to the next term. Multiply, that's for sure. Multiply by... If I multiply by regular 2, I would get +4, but I get -4. So it's actually -2. And I can test it out again. -4 times -2. Yes, that gives me +8. So in this case, R equals -2. And that's very important that we have that. If we just had regular 2, it would give us a different sequence. An all positive sequence, actually. Okay, find the explicit formula. So A sub n equals the first term. What's the first term? 2 times -2 n minus 1. So we have 2 parts of our answer, R and the formula. It's fairly simple, right? And then the last step is what? Based on the question. Yeah, we need the 11th term, so we plug in 11. So A sub 11. That would be 2 times -2 raised to the 11 minus 1. We do this part first, because we have to evaluate what's in the exponent first. So that would be A sub 11 equals 2 times -2 to the 10th power. I plugged in 11 for this n and for that n from my formula. So that's how I get 11 minus 1, and it's the 11th term. It might help you if you put the n minus 1 in parentheses, because you really have to do that first. If you want to, put that in parentheses, the n minus 1. That way you know when you plug in something, do that subtraction first. Don't do the exponent. Like, you don't want to raise it to the 11th. You want to subtract first to get a 10. And then what's -2 to the 10th? So this is 2 times what? 1,000. It's positive because we have an even exponent. 1,024 times 2. So the 11th term is 2,048. This is an exponent. Like a lot of people are still going to screw this up. It's not negative 2 times 10. It's negative 2 times itself 10 times. So make sure you're careful with that. You're using the exponent button on your calculator. Any questions? How did I get the 11? It told me to find the 11th term. And this is an nth term formula. It gives me any term that I plug in. So I just plugged in 11. So that'll be part of the problem. Later on, we're going to manipulate stuff and do it in a bunch of different ways. But here's the reasoning behind the formula. Like yesterday, we looked at the reasoning behind the formula afterwards. Today, we're going to do the same thing. So any more questions on example 1? Like it doesn't get too much more complicated than that, at least for today's stuff. But here's what I want to say. I have a couple terms. Let's actually use this example. So this is kind of a justification for the formula. If I start out with 2 and I multiply it by negative 2, I get negative 4, right? If I multiply by negative 2 again, I get positive 8. Multiply it by negative 2 again, and I get negative 16. By negative 2 again, I get positive 32. I'm multiplying a bunch of different times here, correct? Well, if I start out at my first term, 2, and I plug in this is just saying, because if I multiply by negative 2 twice, that's negative 2 squared. I'm multiplying. Do you guys see? Like if I do x times x times x, that's x to the third, right? Well, I'm doing negative 2 times negative 2 times negative 2 times negative 2. And if I start at my first term and I want to get to my 11th term, I have to do it 10 times. Do we understand that? Because if I start at 1, add 10, I get to the 11th. That's why I have to raise it to the 10th power. Because I want to multiply by negative 2 10 more times after I get my first term. Do we understand that? That's why the formula is what it is. Gives you a starting place and then a number of times doing the operation to get to whatever place that you want. Okay, that's it.